Hello! This is the second in a series of lessons on how to use the Marten development environment to create an application using the Prograph visual programming language. And before we get started on the second lesson, I just wanted to illustrate the kind of application that you can create using Marten and Prograph. And this application is an application used in the analysis of DNA sequences. It has the DNA sequence displayed here, and also there's information that comes from the DNA sequencer in the form of signal strengths. So we plot that, and I just wanted to illustrate that this application can smoothly scroll back and forth, and we can resize all this. And all of this is happening using Prograph and Prograph code created using the Marten development environment. And to illustrate a little bit about what's going on under the hood, we'll open up the debugger, and I'll just put a breakpoint there on drawing the electropherogram, which is the name for the signal that we're seeing. And if I were to go back now and force it to draw, why we drop in there, and sure enough, we're going to get some data points, we're going to get a color, we're going to create a path, we're going to move to that point, then we're going to go in and draw the line, and finally we didn't really draw it at that point, we created the path. Now we're going to stroke it, which is drawing it, and then we're going to drop out, and here we are. So Prograph and Marten are not toys. They are a development environment and a language that is powerful enough to create any kind of application you would hope to create on the Mac. And also currently we are in the midst of getting Marten and Prograph to run on Windows, and we have some early working on Windows right now. So with that behind us, let's learn a little bit more about how to program in Marten. Last time we created a Hello World project. I want to illustrate a little bit more about how to create code. So we are creating code graphically, and we want to understand, or hope in this lesson to illustrate how this works. When you create a Marten application, it consists of code that is contained in cases, and cases are contained in methods. So this method, called example code, will contain 3 cases right at the moment, and in each case we can place code that will be run. So let's get started and discuss the kinds of code that you can create. By holding down the command key and clicking, Marten will set up the generation of a default operation. If I type something in like the number 6.0, it's going to default to an operation called a constant. Now in this menu list, we can see a variety of operations that you can create. The constant operation, the match operation, persistent, an instance of a class, a get of a field or attribute of that class, setting the attribute of the class, a local operation, an evaluate operation, which is a little obscure. We'll hold off on discussing that. If I hold down the Option key, why, I get even more operations I can create: a primitive, external constant, external match, external get and set. And if I hold down the Shift Option key, I even get a little bit more that I can create, particularly an external procedure. So let's kind of create examples of all of these. So we have a constant here. Let's create a match. by selecting the root and holding down the Option key, I get a connecting line, and if I hold down the Command key as well and click, I get the combination of connecting and creating a new operation. And I'll type in the number 7 here, and Marten will help you out and automatically create a match operation. And I've put in the number 7 there for the match operation. Let's continue with a few more. Constant match a persistent. Well, I didn't mean to make it a persistent, but I'll make one now. We'll call it the persistent. It defaults to a constant, but I'm going to turn it into a persistent. And a persistent can have inputs and outputs. I'm going to input the number 8. Just keep it an integer 8. And let's move on to some other operations. An instance. Let's make one of those. We'll call it my class. And I'll go and turn it into an instant operation. And then I will get an attribute of my class called name. And I will get rid of the little x there to the side. I'll have a little bit more to say about the x's here in a little bit. And then we'll have a set operation here. By selecting it and doing a Command D, I can duplicate it. And if I do a Command Shift S, it turns it into a set operation. And we'll set the name to, I don't know, Dexter, which is the name of my dog. What other operations? And we'll have a local here. So we'll make that local. Holding down the Command Shift and L keys turns it into a local operation. And I will hold down the Command key and click very close to the top of the local, which will create a terminal. And I'll hold down the Option key after I've selected. Click there to connect those up. And now I think we have examples, except method here. Well, we'll put in the hello world method, which we've got. I can just drag that over here. And so now we've got the classic methods here. Classic operations: method, constant match, persistent, instance, get, set, and a local. By holding down the Command and Shift and the D key, we can start up the debugger. And just to show that's the case, we'll select the command and we'll start stepping through things. At this point, it's maybe worth taking a step back and just discussing what's going on here. Prograph is a data flow language. What it has are sets of operations, and each operation generates or acts on data and then sends that data out the door to some other operation. So for example, the constant operation, I'm going to hit the return key and it will execute it, generates a piece of data, in this case the number 6. That data is passed to this match operation. Now the match operation will test the value. Every operation in Prograph can either succeed or fail. And you can set a flag to tell the engine what to do when an operation succeeds or when an operation fails. Every operation except the match operation is by default continue on success, and we don't put the flag up. That's why you don't see little X's here on all the other operations, but they could certainly be there. And this is how we deal with creating the control annotation for each operation. The match is generated automatically for you, and the default is to go to the next case if the input does not match the number 7. Well, by holding down the mouse button and examining the data, we see it's the number 6, so it's not going to match. And what this says is if they don't match, in other words, the operation failed, go to the next case. The next case being case number 2. By using the right arrow key, I can go over there, and you know what? I'll just put a breakpoint on it. Then I'm going to go back and double click, and we're back to where we were. Now I'm going to hit the return key. You can all imagine what's going to happen. This is not going to match, and we're going to go to the next case. Bink, and there we are. So we are currently in case 2 out of 3 of the example code method. And by stepping through, we finish executing that code. That illustrated the constant and the match operation. Let's try all this again to see what we can do with the persistent and the instantiate operation, get and set and so forth. I'm going to hold down the Command Shift D keys, start up the debugger, hit the return key to start executing each operation in order. I've executed the input operation. I've executed the constant operation. It has generated a piece of data, the number 6. That's going to be passed to the match operation, and you know what? It's going to not match and send us to the next method. We don't want that to happen, so if we hit the tab key, we will actually step over this. It won't execute it. So now we've jumped over here. The red indicates that this has it's already past that in the execution order. We're now about to execute the myClass operation, the instantiate myClass operation. So it's going to create an instance of what's called a class. The thing is, we haven't created a myClass yet, so if I hit the return key, Marten will actually offer to create some code for you. Do I want to create it? Sure, why not? I'm going to stick it in the Hello World workspace. I'm just going to hit OK. And now we have created an instance of my class. A class is kind of a factory, like the one that makes Ford cars. An instance is a Ford car that comes from that factory. So this is an instance of my class, and not much to it. So I'm going to hit the return key again, and it says this class does not have an attribute called name. Does it not? It doesn't exist. Do I want to create it? Sure, why not? It's going to be an instance attribute. And now if I were to go back here and see what this instance of my class has going for it, it now has an attribute, a property called name, which has the value null. And if I were to hold down the key, why, sure enough, I see that I've created a null value. If I hold down the Command key and click on the name operation, the name get operation, it backs up execution of this code. I'm going to go back here to my class instance, and I'm going to put in something for my name. I'll put in Dexter, the name of my dog. And if I hit OK, I have now modified the instance of that class. And if I hit the return key, it will now grab what's in the name attribute, and sure enough, it's Dexter. Okay, well, it turns out I don't have any persistence. Persistents are somewhat like global variables. They are ways to store data that's accessible by every piece of code in your application. I haven't created this one yet. Again, Marten offers to create it for me. Sure. I am going to, we've stuck the number 8 into the persistent. Let's back up and execute it again. It will now generate a piece of data, and what did it generate? Why, the number 8. So that's a persistent, and if I go back over here to my hello world space, I see that it has created the persistent for me. And if I go here, I see that it's created the class, my class, for me. So back over here, I'm going to stick Dexter in there. I think I'm going to change this to some new name. So I'll edit it to Digger, another name of a dog, stick it in there, and now if I examine it, why, it's Digger. I'm going to go into this bit of local code. So a local is a method that exists entirely within the containing method. If I hold down the command key and the down arrow, that is the step into command, and I can step into my local. I execute the input operation. I get an instance of my class with the name Digger. I don't think I'm going to do much more than that. I'm going to edit it so that I pass an instance out. I'm going to execute the output operation, and I get an instance of my class. Finally, the hello world method has already been created. By holding down the command key and the down arrow, I can enter it. And we're going to come through, create a constant which generates a piece of data, hello world. We're going to execute a primitive operation called show, which puts it up on the screen for us. And then we're going to execute another constant operation which creates the number 0, passes it to the output operation, which then feeds it to the output root of the hello world method, and we have the number 0. Hitting the return key executes the final output bar, and we're done executing code. So this concludes the first lesson that really details what's going on with the code. We have, in this particular case, how many operations? 1, the input, 2, the constant, 3, the match, 4, the persistent, 5, the instantiate or instance operation. I think I'm up to 6, the name, 7, the get, and 8, the local, and finally 9, the output bar. So we've illustrated 9 different kinds of operations here in this example code, and we'll take this up again in the next lesson where we will connect more of this together and discuss controls.